Hello everybody, it's Mr. Strager, and welcome to another Algebra 1 video. This is going to be a video about section 1.2, solving multi-step equations. Now, last time we talked about how to solve one-step equations, and we talked specifically about using the inverses and undoing everything attached to our x. But this can sometimes be a little bit problematic. Let me give you an example. Let's say, for instance, that x equals 2. This is a no-step equation. There's nothing to be done here. It's already solved because the x is by itself. But last time I also mentioned that using any of the properties of equality, I can really do whatever I want to these numbers as long as I do it to both sides. So let's say just on a whim, I decided that, hey, I want to multiply both sides by 3. Well, if I did that, then I end up with 3x equals 6. Of course, my value for x hasn't changed. That's because I did the same thing to both sides. X is still 2, because 3 times 2 is 6. Let's say, though, I didn't like what I just did. I didn't like that I just did multiplication. I want to undo it. Well, we would use our steps that we learned last time. To undo multiplication, we would divide both sides by 3. This is going to be a very important skill to get good at, is being able to go forwards and backwards with these equations. All right, that's how you go forwards and backwards. Let's go back to this 3x equals 6. Because I'm not done yet. I want to make my equation just a little bit more, shall we say, interesting. In fact, I want to make my equation a linear equation in one variable, or at least in that general form. This is still a linear equation in one variable, but it's not in the general form. The general form is when this side equals 0. So let's say just on a whim, I subtracted 6 from both sides. Well, 3x minus 6 is not negative 3x. Remember, set your variables to be equal to some object, and set everything that's not a variable equal to a different object to see if you can combine them. In this case, you can't. 3 red crayons minus 6 elephants, you can't do it. So we keep 3x minus 6 as our expression. And 6 minus 6 is 0. So I'm where I want to be. I'm in the general form of a linear equation. Here I subtracted, and here I added. Because if I wanted to get back to this form, to 3x equals 6, I just need to get rid of the negative 6 by adding 6 to both sides. This is a multi-step equation now, because it takes multiple steps to get to a place where x equals 2. You would need to add 6 to both sides, then divide by 3 on both sides. That's the essence of what we're really going to be working with today. However, there's one other step that is very important. To solve a multi-step equation, simplify each side of the equation if necessary. So keep that in mind as we go through these example problems. You have to make sure that if you can combine any terms at the start, you do that first. It makes it so much easier in the long run. So, let's try out a problem together. Let's say I'm given the problem x divided by 2 minus 4 minus 7 equals 15. Now already, many of you may spot something that we can do at the very start, and that is to simplify each side of the equation. 15 is as simple as 15 is going to get. But if I'm subtracting 4 and subtracting 7, couldn't I do it in less steps? I could rewrite this as x divided by 2 minus 11 equals 15. Now, here is the question. Do I want to undo this subtracting 11 step first, or do I want to undo this dividing by 2 step first? And it's hard to say unless you know the rule. Remember Pemdas, the abbreviation that stands for parentheses, exponents, multiplication, division, and addition and subtraction? This is a way to simplify expressions when there's no variable involved. When there's no variable involved, you use Pemdas going in order to simplify. For instance, if I had 3 times 2 times 3 plus 7, the way you would solve this is you would do the parentheses first, so you do 3 plus 7 to get 10. Then you'd have 3 times 2 times 10. We don't have any exponents, but we do have some multiplication and division. 3 times 2 times 10, you just read from left to right on that multiplication division step, is 60. When there's an x involved, though, we can't simplify the expression. If this 3 was an x instead, we wouldn't have just a number to simplify. It would still be x plus 7. And this would still be 2 times x plus 7. Pemdas breaks down in this case, and we can't actually use it. However, what we can do is we can use Pemdas as a framework for how to take the equation apart bit by bit. Imagine you're building a sandwich. You put a piece of bread on the bottom, maybe put a little bit of lettuce there, you put a piece of Swiss cheese, then you put another piece of bread on top. And you realize, oh shoot, I forgot the turkey. Well, you wouldn't just throw the turkey under the lettuce. You can't do that. It's already a stacked sandwich. Instead, you would have to take off the top piece of bread to put the turkey inside. That's the same way we take apart equations. You have to take it apart in reverse order of the way you put it together. Pemdas is the way we put equations together. So if we want to take this equation apart bit by bit, we're actually going to start at the bottom and work our way up. Let me show you what that means. In this equation, let's take a look at reverse Pemdas. What's the first step if we're going in reverse? Well, the first step is going to be this addition-subtraction. To get rid of addition and subtraction, we have to first look and see if there is any addition and subtraction in the problem. And there is. We have minus 11. To get rid of addition and subtraction, we know that we have to do the inverse operation. What's the inverse of subtraction? Addition. So we're going to add something to both sides. And what we're adding to both sides is whatever will help to get x by itself, whatever will get rid of negative 11. So we plus 11. When we do that, these two will cancel out to 0, just like last section. X over 2 equals 26. Now we're left with a one-step equation. So, with this, what we have left over, we just need to get x by itself. Is there any more addition and subtraction we can undo? No, because we simplified at the start. See, this is why simplification is so important, because otherwise we'd be stuck here for an extra step, and that's just a lot of hassle. It would still work, but it'd be a lot more steps and a lot more effort. So we move on to multiplication division. Is there any multiplication or division? Yes. We're dividing by 2. To undo dividing, we multiply. And specifically to undo dividing by 2, we have to multiply by 2. And we're left with x equals 52. That is how you do a multi-step equation. Now, not all multi-step equations are created equal. Some of them are much more complicated than others. If you flip the page to page number 10, let's take a look at one of these more complicated examples. Actually, you know what? Let's flip all the way over to page number 11. Let's do something crazy here. Let's take a look at number 11. Number 11 is a lot going with it. But in order to get started, we have to ask ourselves, is there any addition or subtraction we can undo? We might say yes because we see a plus 7, but remember, this is in parentheses. And according to our reverse PEMDAS, parentheses are the last thing we want to touch. So actually, we don't have any addition or subtraction outside of the parentheses. Do we have any multiplication or division? Well, it's a little bit deceptive, but yes, we do. It's this 3. Because the 3 is outside of the parentheses, this is really 3 times whatever z plus 7 is, equals 21. Now, the reason why I picked this is because there are 2 different ways of solving this problem. Some of you may recognize a little bit of a rule we can use called distribution, wherein we multiply 3 to everything in the parentheses. If you consider that simplification, then do it. That is totally okay to do. You'd end up with 3z plus 7 equals 21. And we would solve this very similarly to the last problem. But I'm not going to do that. I'm going to look at this as if it was 3 times z plus 7 equals 21, just to show you how you can still solve it even in this state. Because this is 3 times this entire thing, and we want to get our z by itself, and we have to do multiplication before we do parentheses, we're really looking to get rid of this 3 times. To get rid of multiplying by 3, of course, we have to divide both sides by 3. We end up with z plus 7 equals 7. Well, now it's a one-step equation. We want to get rid of everything attached to the z. The only thing attached is a plus 7. So we're going to subtract 7 because that's the inverse operation. What we're left with, though, is interesting because these 2 cancel out to 0, leaving us with just z. But 7 minus 7 is also 0. It's okay for your answer to be 0. Z equals 0 is our answer. Let's do just one more that was a little bit tricky for those of us in class. And the one I want to take a look at is actually going to be number 3. 17 equals z minus negative 9. This one is actually technically just a one-step equation, but it looks very weird because we have this double negative. Again, there are 2 ways of looking at this. If you look at this and say, hang on, minus negative 9, well, I know that minus a negative will give us a plus. Then yeah, you can simplify it in that way if you would like to. Plus 9. And you've simplified, now you can solve it as a one-step equation. But I'm not going to do that. Again, I'm going to take a look and see if I can solve this as is. What's our unknown? Z. So that's the thing we want to get all by itself. What's attached to it? Well, the number that's attached is actually negative 9. How do we get rid of a negative 9? Well, we have to look at the operation. The operation being used is subtraction, so we know we're going to have to add something to both sides. But what? We add whatever cancels out minus negative 9. The opposite of subtraction is addition, and we want to use the same number that we're given. To get rid of minus negative 9, we add negative 9 to both sides. These ones will cancel out to 0, leaving us with just z. And 17 plus negative 9, well, you want to simplify that, that's the same as 17 minus 9. That gives us our answer of 8. For a true challenge, I would recommend trying out question number 6. That was the hardest one on the page. But otherwise, the rest of the practice is yours to try out. Thank you so much, everybody. Have a great rest of your day.